Look around. Our entire world pretty much runs on light. It's in the clean energy powering our homes, the invisible data connecting us, and even the tools that are building our future, such as lasers and optical sensors. But what if I told you this was discovered over a century ago, thanks to a single brilliant idea? An idea so controversial to classical physics, it would help advance quantum theory. Back at the turn of the 20th century, physicists were scratching their heads over a strange phenomenon called the photoelectric effect. They observed that when light hits a piece of metal, it would sometimes knock electrons loose. But here's the weird part. Their observations made no sense. According to the physics of the time, a brighter light should have sent the electrons flying off with more energy. But that's not what happened. Experiments showed that brighter light only knocked more electrons loose, not more energetic ones. And strangest of all, if the light's frequency was too low, nothing happened. No electrons, no matter how bright the light was. In 1905, a young 26-year-old patent clerk at the Swiss Patent Office named Albert Einstein came along with a radical idea. He proposed light isn't a continuous wave, but a stream of individual packets of energy. He called them light quanta. Today they are called photons. Imagine a piece of metal. Inside the metal are tiny particles of electrons. The electrons are sort of like marbles stuck in the metal. But the electrons aren't locked in that tightly. You just need enough photon energy to knock them loose. The photon's energy depends on its frequency. A photon is a tiny bundle of light energy. Light also behaves like a wave, which means it vibrates back and forth. How fast it vibrates, its frequency, decides how much energy that photon has. It's a law of nature. High-frequency light waves vibrate very fast, like blue light in the visible spectrum or ultraviolet light. Low-frequency light waves vibrate more slowly, like red light in the visible spectrum or infrared light. If a photon doesn't have the required frequency, then it doesn't carry enough energy to free an electron. As a result, nothing happens. No electrons are emitted, no matter how many low-frequency photons hit the metal. If one photon has enough energy, it hits an electron and knocks it out of the metal immediately. When the electrons that are knocked free from the metal are collected, their movement creates an electric current. In other words, light being converted into electricity. That's what Albert Einstein figured out. His explanation is beautifully simple once you see the leap he made, which basically was light is made of packets of energy called photons, and each photon has a specific energy based on its frequency. One photon can hit one electron and knock it completely free from a material. At the time this idea was considered radical, even the physicist Max Planck, who introduced the concept of energy quanta in 1900, was skeptical of Einstein's photon interpretation. But this one simple idea explained the photoelectric effect and would go on to win Einstein the Nobel Prize in Physics in 1921. The photoelectric effect became a foundational piece of quantum physics. So a neat solution to a physics mystery. But what does that have to do with you? Well, the idea that light can free electrons is the principle behind many modern technologies. For example, solar panels use a related effect. Photons from the sun hit a semiconductor, giving electrons enough energy to move. Those electrons don't fly off into space. Instead, they flow through a circuit, creating an electric current that can power your computer, your home, and countless other devices. That same secret is in your pocket right now. The sensor in your phone's camera, it's basically a grid of microscopic light detectors. When you take a picture, photons flood through the lens, striking the sensor and releasing electrons that are converted into the pixels that make up your photos. This principle is also at the heart of automatic doors barcode scanners, and even the fiber optic cables that are likely delivering this content to you. All these rely on the same principle that Einstein explained: photons transferring energy to electrons. If you like this glimpse into the science that shaped our universe, be sure to subscribe for more stories like this. So from an experiment that didn't match the predictions of existing physics to the technology that shapes our daily lives, Einstein's insights remind us of how a single new perspective can change everything. Who would have thought that a fundamental question about the nature of light would one day quite literally power our world? In our next Quantum Minds episode, we dive into the story of the Danish physicist Niels Bohr, and how his radical solution to a crisis in atomic theory reshaped physics and laid the foundation for lasers and quantum computing. Until next time, remember, stay curious and keep exploring. Thanks for watching.